Welcome to the project demonstration of hybrid energy management system for islanded microgrid. So here we are using microgrids with help of renewable source, the solar panel, and the voltage of the solar panel is given as input to this battery pack. Through the another charging circuits, we are making use of super capacitors. So we are using three super capacitors of rating 1 farad with 5.5 volts capacitors which are connected in series. So through that the input voltage is given to the battery for storage purpose, and before this we are making use of a buck boost converter. So mainly here we are using this for boosting purpose. Whenever the voltage from the solar panel is not sufficient to charge battery pack along with super capacitors, then the system will do the boost operation to get the sufficient voltage for charging of these two storage devices. And also we are providing a secondary source from the grid. We are going to charging battery pack through this charging circuits, and once the battery pack is charged continuously, we are going to provide the power supply for the utilization purpose. As a grid application purpose, we kept this inverting circuit which is used to convert the DC 12 volts 1 amp to the AC 230 volts directly to this load. And also we are providing that same to this monitoring management purpose to the Arduino Uno board. From there we are going to measuring the voltages from the solar panel and super capacitors, nothing but the buck boost converter voltage as well as battery voltage. So these three voltages continuously monitoring on display of LCD screen which was interfaced to the Uno board at pin number 2 to pin number 7, and voltage sensor from the solar panel to the A0 and super capacitors A1, A2 for this battery pack. And coming to the components, so the flow is from the solar panel, we are providing that input to the charging circuits. So this is one charging circuit. So solar panel output is given as input to the charging circuits and voltage sensor. So the voltage sensor consists of two resistors. So 1, 2 and 3 voltage sensors, same pattern, that is 10K and 1K. That is a 10:1 voltage ratio. That's a potential divider ratio. Means whenever the voltage is 12 volts from the generated source, and the output of this voltage sensor is 1.2 volts only, so that the microcontroller can handle that voltage, because microcontroller can't handle the 12 volts directly. That's why we kept the potential divider ratio to make it as below 5 volts. So in the programming Arduino, we write the condition of whenever the voltage is getting from this voltage sensor is 1.2 volts, then multiply that with 10, as we are using the potential divider ratio of 10:1. So this is the voltage sensor configuration. And coming to the charging circuit configuration, so on this we can see the 4 diodes. So on the both charging circuits we can see the input was given to the 4 diodes. So there we use these 4 diodes as a rectification purpose. So whenever we are providing AC input from this transformer, which is used to step down the 230 volts AC to 12 volts of AC, and 12 volts AC will be converted into the 12 volts of pulsating DC with the help of this rectification. And after that the filtration will remove the pulses and provide us the 12 volts DC constant. And these two diodes will acting as a unidirectional current flow, means whenever the battery is fully charged, it will block the current flow from the battery to the transformer, so that we can protect the transformer from reverse current from the battery pack. So here we need to connect A to should be connected to the A slot. This is for charging from the grid, and B to this B slot. This is from the boost and super capacitor slot. Okay, and the next on these charging circuits, which is same rectification, filtration and unidirectional current flow, but here these 4 diodes will act as a polarity corrector. Their rectification AC to DC, but we are providing DC to this charging circuits. So these 4 diodes will convert the polarity correction purpose, means whenever we place the solar panel in reverse polarity based, then that will be rectified to plus, minus to minus, so that we can protect the battery from reverse polarity damage. And this is a boost converter which is getting pulse signals from the Arduino Uno based on the voltages measured from this solar panel. So this is a pulse signal directly from this Arduino Uno board, and these are the voltage measurement purpose of the boost, nothing but the super capacitor boost along with our solar panel. And here is the battery measurement voltage. Okay, and coming to this section, as we discussed, Arduino is continuously monitoring and controlling that and displaying on the LCD screen. And this is the inverter. So this inverter consists of 2 MOSFETs along with one IC. So the one IC will convert the 12 volts DC to 12 volts AC. So this is the inverter stage. Then after, the 12 volts AC will be step up to the 230 volts with the help of this step down section. So any inverter board consists of the two stages. One is inverting DC from DC to the AC, and then the AC will be step up to the required voltage. So in our project, we need to invert that 12 volts AC to 230 volts AC. So that's the purpose of this stepped up transformer. So this is all about the inputs and to the outputs. So if you want to charge a battery from the grid, so just connect this to the 230 volts, then the charge light will be indicated. So it will get fully charged in a duration of 4 hours to 5 hours. Till the duration, the battery should be under charging. So after that, automatically, if the battery is fully charged in between time, then automatically this circuit will block the current flow to the battery to protect it from overcharging. So same for the solar panel also. Just place the solar panel in the sunlight. You can see now it is normally low intensity, as sun intensity also low on the solar panel. When we place this under the full sunlight, it will get the full brightness and it will get fully charged in a duration of same 4 to 5 hours under the full sunlight. So if we connect the both at a time, then it will get fully charged in a duration of 2 hours only, so that we can save the time by getting the more power from the two sources. So this is all about the project explanation, and let us see the output. So this is on switch. Just when on that, welcome to the project message, and there we can see the battery voltage, solar panel voltage and supercapacitor voltage. As the solar panel voltage is very less, so whenever the solar panel voltage is more than 8 volts, then only the boost operation will be done to get sufficient voltage and current. So when we place the flashlight on the solar panel, the voltage will be increased. You can see it is increasing to the, and when the solar cells are covered, you can see low voltage. Okay, so from there we can utilize that to the grid. So it's a microgrid application, we are using that for converting the DC to AC application directly. So there's a microgrid section along with sources inputs along with the DC to DC converters. So these two are this is the DC to DC converter along with the buck boost converter, and this is AC to DC converter whenever you are providing the grid inputs, and from there monitoring section along with the super capacitors, storage and utilization to the grid section. Thank you.